What's up, team? In this video, I'm going to cover ways to support your horsepower goals and modifications electrically and electronically. The goal of this video is for the team, that's you, to walk away with a better understanding of how things like a ground cable and a tune can play a role in making reliable power. Now, I'm not going to act like after watching this video, you'll be able to make a wiring harness for a race car, but what we will talk about are the fundamental things that you should consider and or do when you plan to increase your power. Now, we'll reference some material from my mechanical power support video, so if you haven't watched that, you should. And it's not because I want clicks, it's just so we're all on the same page. And as usual, I'll put timestamps in the description. But before I get started, I just wanted to say thank you to all my subscribers. I appreciate your views, comments, and questions, and hopefully I'll get to see some of your projects in the future. So feel free to share my videos with people who love project cars just like we do. Okay, so first let's talk about the difference between electrical and electronic components. Electrical components conduct electricity and or are powered by electricity to perform relatively simple tasks. Electronic items are powered by electricity but are higher functioning than their electrical counterparts. For example, wires, traditional light bulbs, and basic switches are electrical components. A radio, instrument cluster, and an ECU are electronic components. It may seem elementary, but as you become more advanced, how you route your wiring harnesses, locate and interact with your electronics will depend on your understanding of these systems. For example, it would be a bad idea to have an airbag circuit near primary wires or ignition coils. Electromagnetic induction from these systems could cause airbag deployment, and this is because airbag circuits are very sensitive to voltage changes. And I'm pretty sure none of us want to get smacked by an airbag, so there's that. Now, you can have an electrical component that uses electronic devices, so it's important to keep an open mind and understand that different things can work together for a better overall result. And that goes for a lot of things in life. Wires, wire protection, and wire routing. On a stock car, the wires are protected and operate fine for their application. But once you start changing parts and increasing power, things can get a little hokey. Increasing power significantly will most likely increase underhood temperatures and potentially expose all of your systems to heat that they weren't designed for. In addition, some aftermarket parts don't come with heat shields and or require you to reroute or relocate other items. Now, if I'm relocating things, that means I'm putting them in places they don't necessarily belong. Now, understanding that, I'm going to support my power upgrades by protecting my electrical and electronic components from heat and the other elements. Now, I'm going to do that by avoiding contact with hot surfaces. I'm going to cover my wires or wiring harnesses with a protective sleeve. I'm going to put heat shield between the hot surfaces and the rest of the engine bay. And I'm going to use wiring that is designed for outdoor high heat environments. Now, if I'm relocating components, I'm going to put them in places where they're protected from the elements as well. Taking these precautions will increase the reliability of your project and give you peace of mind while you're driving. So now that that's done, let's get into some heavier material. Referencing the mechanical support video, power can be made by improving one or more of the events of the 4-stroke cycle. I'm going to focus on the ignition event, also known as the power stroke. Ignition is where your air-fuel ratio is ignited via the spark plug and combustion occurs. When you significantly increase the engine's power output, there will most likely be more air, more fuel, more pressure, and more heat in the combustion chamber. Increasing those elements make it relatively harder for the spark to occur reliably. All these factors will determine how powerful your ignition or spark should be when you want your spark to occur, if you want multiple sparks, and the type of spark plug that can perform those tasks. With all that being said, how can we support the ignition system for power increases? Well, let's think about the basics. To make spark, you need electricity. And for what we know from batteries, current flow comes from two poles, a positive pole, aka B+, and a negative pole, or ground. For current to flow, the electrons from the negative pole have to be able to reach the positive side. In the case of spark plugs, the engine assembly is your ground, and the B+ comes from your ignition coils. To help that spark, I want to make sure my positive and negative connections are optimized. This means my connections should be clean, the gauge of the wires are sufficient to carry the current, and all the other components or the environment do not interfere with my signals or flow. For electrical support, I suggest using several fresh ground cables mounted on different areas of the engine and throughout the chassis. The OEM grounding straps could be worn, corroded, or simply not able to carry the current that you may need. It's common for other components such as sensors and harnesses to use the engine and chassis as a ground, so changing the current flow without changing the capacity of your system via adding grounding cables can cause some electrical gremlins. Think of it like that one outlet during the holiday season. Yeah, we've all seen them. It's just not a good situation. Now on the B Plus side, you can replace or upgrade your coil or coils, your spark plug wires, and the distributor if you have these components. On modern vehicles with coil over plug systems, the OEM coil packs are usually good for significant gains. Now if you're doubling or tripling your power, then everything is liable to change. And when it comes to spark plug selection, I suggest starting with the OEM part, and as you make more power, that's a conversation you're going to have with your engine builder and or tuner. Now for the electronic side of ignition upgrades, there are a few choices and they depend on the type of ignition system you have. If you have a distributor system, you can install an ignition module that controls spark output. Its common name is an ignition box. You can also convert the single coil to a digitally controlled coil packs or a coil over plug system. Now if you start with a coil over plug system, electronic upgrades for the B Plus side come in the form of ECU tuning. Whether you have a standalone unit or flash your OEM ECU, this is what needs to be done. And it's a great segue to the next topic, which is tuning. Tuning is a topic that gets a good amount of attention, but it's still not talked about or done enough. You can tune mechanically and electronically, but we're going to stick on the electron side of things for now. Now let me be clear, this section is for vehicles that have an ECU. Now I don't care what kind of vehicle you have. If you have installed a power modification, tuning will optimize the situation. Now some vehicles can cope with changes better than others without a tune. But at the end of the day, getting a tune is the best way to support power modifications electronically. Hands down. Now that I've said that, let's take a step back and talk about what tuning is and why it's critical. Tuning is adjusting the vehicle settings to best fit your goal. When it comes to modern vehicles, many adjustments and parameters come into play. The ECU, whether it be the engine control unit or electronic control unit, can control several things in your vehicle. The newer your vehicle is, the more independent ECUs you will most likely have. These independent ECUs will be dedicated to things like the engine, the transmission, safety systems, the media player, etc. As a side note, even with multiple ECUs, there will always be one that acts as a controller for all of them. For vehicles to operate properly, these ECUs are pre-programmed with some basic values to allow them to start and operate reliably when you turn the key or push the start button. Once the cold start or open loop cycle is over, the ECU will go into closed loop mode and make some adjustments. Even when the vehicle is at its best operating condition, the ECU relies on some pre-programmed constants or assumptions that it believes will always be true or good no matter what. And if these values are violated, that's where you have your check engine lights, your poor performance, and complete failure come into the picture. The ECU monitors operating conditions via sensors and make adjustments accordingly. When cars are built in the factory, the ECUs are programmed with a relatively generic code that assumes every component on every car in the assembly line will fall in a certain range. And what we know from real life, that if I have 1,000 engines, 1,000 transmissions, and even more sensors, they will all have some variance on how they perform. Now, since the ECU is relying on the sensors to make real-world decisions, there's room for performance loss. And this is how some tuners are able to make more power and better gas mileage with a completely stock vehicle, and I'm not including changes to boost. But to be fair, OEMs are relatively conservative with their tunes because they want to maintain reliability and warranty. So by no means am I saying that they are incapable. Now in terms of performance, some of the constants or parameters that are important are the volume or size of the mass airflow housing, fuel injector flow rates, acceptable manifold pressure, target air-fuel ratios, timing adjustments, and transmission shift points if you have an automatic transmission. When you change your air intake, your injectors, exhaust, etc., you are changing the volumes and or the flow rates of the system significantly. Without a tune, the ECU is just guessing what it should or shouldn't do. It's like driving blindfolded and the passenger yelling out directions. You might get somewhere, but it's not going to be pretty. To keep the analogy going, getting a bass tune is like taking the blindfold off, and getting a dyno tune is like getting a driving coach. Now I know getting a tune is not cheap, but neither is replacing an engine or a vehicle. This is why you have to plan before you buy and install. My advice is to upgrade and tune together. If you want an intake, turbo, and exhaust, don't install them and say, I'll get a tune later. You aren't doing yourself or the car any favors. Be patient and get them done together. You won't regret waiting. Now, I will caution you on that, because tuning can literally be done by anyone. All you need is the software. With that being said, it's up to you to figure out who to put faith in to tune your project. But what it also means is that you can learn how to tune yourself. And if you watch my videos, you know I encourage learning, and that still applies here. I will say that you have to be really patient because learning tuning can be a little bit taxing. Now, in terms of performing the tune, there are some people who tune by driving on the road, and that's fine if it works for them. I prefer dyno tuning because it's more consistent and I believe it picks up on small changes a little bit better. And it also allows me to reference data and charts without having to convert data logs. And even if you don't plan on tuning your project yourself, it won't hurt to do some reading and watching videos on the subject. And that's because knowledge is literally power in this case. The next way to support your power modifications is to monitor your vehicle's operation. Even if everything was done correctly and is working smoothly, you should keep an eye on things via the gauges. Gauges are a great tool if you choose the correct items to monitor and you know how to read them. When read properly, it is possible to detect an issue before it becomes severe, or it'll help you in vehicle diagnosis if there is a failure. Now, everybody's preference and project is different, so I cannot say what is or is not necessary, but I will go over some parameters that I believe are vital. Oil pressure and temperature. Oil pressure can indicate if there's a flow issue, viscosity issue, or a severe leak. Reading low or no pressure may allow me to cut off the vehicle before a catastrophic failure occurs. And the oil temp will allow me to know when the oil reaches operating temperature or goes above the norm. When it's cold, I know not to go full boost, and if it's pretty warm, I'll be a little more cautious with my aggressive driving. Fuel pressure and lambda. Fuel pressure is really helpful for tuning because different power goals and aftermarket systems will require different fuel pressures. It could also be very helpful if there's a no-start condition where you want to confirm that you're getting fuel to the combustion chamber. The lambda gauge lets me know how much fuel is being burnt and how the ECU is adjusting my air-fuel ratios relative to the load conditions. If my air-fuel ratio is too high or lean when I'm wide open throttle, I'll know that there's an issue. And if it's constantly dumping fuel or rich in all conditions, I'll have to fix that too. Vacuum/boost gauges are very helpful as well. They are a good indicator of your engine's air systems. A pinhole-sized leak can cause drivability issues, and sometimes you can catch an abnormality with a gauge attached. The gauge will also let you know if you're hitting your boost targets or if there's an over or under pressure issue. Now, your coolant or water temp is important, especially on vehicles that are driven hard. I use my OEM temp gauge for now, but having the numerical values available is very helpful when it comes to making sure that you're in operating range. Now, there are many more gauges and monitors that cover a wide range of applications. These are just some of the basic ones. Which gauges you use should be choose on your knowledge of how to read them and the project itself. Okay, so now let's review. Use wiring appropriate for exterior high temperature applications and make sure you protect them with heat shields. Confirm all of your connections are clean and add grounding straps to strengthen your current flow. You shouldn't install parts without plans to get it tuned, because why? Tuning is essential for making reliable power. And gauges, just like any other tool, they're only useful if you know how to use them, also known as reading them properly. And last but not least, learn as much as you can about your vehicle, so when it's time to purchase, apply, and use the items, you're doing it the right way and you know what and what not to get. Alright, so I hope this video was helpful and you get to apply some of these things or all of them to your project. So don't forget to leave a like and subscribe. It helps me bring you more original content. Now, if you have any suggestions or questions, feel free to leave them in the comment section. And stay tuned, and thanks for watching.